We are facing trillions of dollars in potential economic losses as global temperatures rise. Yet the transition to a green economy is projected to create millions of new, high-paying jobs. This duality exists because a warming planet is a wicked problem, a challenge deeply entangled with every facet of human society, from agriculture to global finance. Our current education system is poorly equipped for this. We isolate climatologists in one building, business majors in another, and mathematicians in a third, preventing the very collaboration we need. Understanding the physics of trapped greenhouse gases is only one part of the equation. Without a structural mechanism for economic and logistical change, scientific awareness alone leads to paralysis. Scientists have successfully modeled long-term projections and built a massive, undeniable global consensus on the state of the crisis. But translating that consensus into reality means solving the brutal logistics of implementation, structuring carbon markets, incentivizing private investment, and decarbonizing global supply chains. This creates an implementation gap, the space where theoretical climate science stalls out before it can be turned into profitable, scalable action. To bridge this gap, we need a problem-solving framework that connects scientific data directly to economic execution. FUSIONSTEAM provides that framework by integrating business, mathematics, and climate change into a single cohesive discipline. This risk probability curve for a coastal city demonstrates how advanced math becomes the literal language of climate action, revealing concrete threats. These mathematical models allow analysts to accurately price carbon credits and assess climate-driven financial risks facing global markets in real time. Once mathematics maps the risk, business strategy provides the engine for scale, using circular economy models and sustainable finance to build viable solutions. Because the private sector must drive the majority of the global transition, fusing business strategy with climate modeling is a requirement for funding our survival. We can see this convergence in the design and launch of a sustainable community solar farm. Physical science and engineering design the hardware, while the arts provide the design thinking and communication strategies needed to secure local community support. This topology map represents the mathematical layer, where data science calculates the optimal placement of nodes to balance the energy load on the grid. Finally, the business layer integrates investment inputs and market incentives, turning an optimized physical grid into a profitable venture. No single discipline can build this farm alone. It requires convergence thinking to navigate the economic, environmental, and technological hurdles simultaneously. The modern job market has shifted. Employers now demand systems thinkers who can manage the complexity of intertwined global systems. Fusion-style teams, groups that blend business acumen, tech innovation, and domain expertise, are rapidly becoming the industry standard. By anchoring STEM to real-world business and artistic communication, we make the field more accessible, drawing a more diverse range of talent into sustainability roles. Educating this new generation of problem solvers is the most direct way to accelerate national goals like net zero targets and sustainable development. Modern leadership requires a mastery of the intersection between business strategy, mathematical modeling, and climate science. We need leaders capable of calculating environmental risks, engineering the technical fixes, and building the resilient enterprises required to deploy them globally. Success now depends on converting climate data into integrated action, moving beyond the simple collection of environmental facts. FUSIONSTEAM provides the framework to scale these insights, turning academic knowledge into the resilient infrastructure and sustainable ventures necessary for a viable future.